So I started talking about this earlier, that you don't always have to keep things real. Sometimes maybe you don't have to keep things real. So look at this example. This example is, of course, is a basic one. We've done it many times. It's the arc tangent, but the partial fraction decomposition gives you another look at it. It tells you that well, let's write now. 1 over x squared plus 1, of course, is this can be factored as x minus I, x plus I, as in the square root of -1. That would suggest that maybe we can factor it as x minus I, x plus I with a or b on top. And in fact, you could. You could go on and multiply by the least common multiple. That would give you 1 is equal to a times x plus I, b times x minus I. This shall be true for all possible x's. This should be true for all possible x's, so we try x equals I. What happens when x is equal to I? I would get 1 is equal to a times I plus 0. So 1 is equal to a times 2i's. Implying, of course, that a should be equal to 1 over 2i. What happens if x should be equal to -i? Well, it could. So then 1 would be equal to 0a plus b times -2i. This goes away, so b is equal to 1 over -2i. This tells you that our original rational function, 1 over x squared plus 1, could be written as 1 over 2i, that's the a, times 1 over x minus I, plus -1 over 2i times 1 over x plus I, that's our b, a and b. Which would imply furthermore that if I take the integral of this, it's the same thing as taking the integral of this and that. And of course these are really easy. These are, look, I could do this in my head. Integral of 1 over x minus I dx plus, or -1 over 2i integral of 1 over x plus I. I could do this in my sleep now. 1 over 2i, this would be a log function, ln of x minus I plus -1 over 2i log of x plus I plus a constant. Wow, what a nice problem. Shakes your head a little bit, huh? Shakes your brain. Because look at all the stuff we're doing here. We're doing complex numbers, logs of complex numbers. We don't even need absolute value signs anymore. This could be brought up as an exponent. All kinds of amazing things are happening here. And even more amazing, had you done it the other way, the old-fashioned way. Let's go the old-fashioned way. Integral of 1 over x squared plus 1 dx. You would have said, hey, that's just arc tangent of x. On the other hand, we're getting that it's equal to this. On the other hand, it's equal to that. So which is it? Is it this, or is it this? Or could it be this amazing thing that arc tangent? Could it be that? No way. Could it be that arc tangent is equal to that piece? Well, plus or minus a constant. Some amazing stuff, man. Fearlessly doing partial fraction decomposition with complex numbers. Fearlessly going where the logic points us, and then fearlessly concluding that these two have to be equal up to a constant. Some nice stuff. Okay, so never be afraid to go complex. Never be afraid to not keep it real. Alright? Alright, come back for another nice example, maybe.